I said in the last video that we could improve on the implementation of our queue, and I asked you to think about the case where we add 2 employees and then we remove one, we add one, we remove one, add one, remove one, and we keep alternating like that, because in that case we never have more than 2 employees on the queue. And so if we've created a queue of length 10 or of length 5, the queue should never need to be resized because we always have fewer employees than the size of the queue. But will that be the case? So I've created a new project and I've got the exact same code in here. And this is the code we're going to update to improve the implementation. But first, let's demonstrate what's wrong with this implementation. So back in the main method, I've added the code for doing the alternating adds and removes. I'll just uncomment that code. Underneath, I have our old code that we did in the last video. And what I'm going to do here is I'm going to say array queue equals new array queue, and I'm going to make it 5 so we don't have to do a ton of adds and removes. So down here I'm adding Jane and John, and then I remove Jane, I add Mary, I remove John, I add Mike, I remove Mary, I add Bill, I remove Mike, and then I add Jane again. And so because after the first 2 adds, I'm removing, adding, etc., we never have more than 2 employees on the queue, and our queue has a capacity of 5. And so we shouldn't expect this queue to be resized. So let's go into our ArrayQ class, and I'm going to put a breakpoint right here. And I'm going to run the debugger, and we're going to see if when we run the main method, if this breakpoint is hit, because if it is, it means we're resizing the array. So to run the debugger, instead of hitting the green arrow, I'll hit the little bug here. So let's run. And boom, we hit the breakpoint, which means that we're trying to resize our array. Now, if we go back to the main method, so I'll go to here's our call stack that we've talked about. So right now we have main and add on here. I'll go to main, and you'll see that it's when we come to add Jane Jones that we're trying to resize the array. So before we do that, we've added 5 employees, and sure, we're doing a 6th add, and our capacity is 5, but we never have more than 2 employees on the queue. So there should still be room, but apparently there isn't. And I'll tell you why. If we come down and look at the fields for this class, and we look at the queue field, we'll see that the only employee on the queue right now is Bill End, which is what we expect from this code, because the last remove removed Mike, and so all we have is Bill when we come to add Jane. And he's at position 4. And here we have a line saying not showing null elements. So that means that positions 0 to 3 in the array are null. But if you look at our front and back fields, our front is 4, and that's right because Bill's the only guy on the queue and he's at position 4, so he's at the front, and the front is 4. But the back is 5. And if we look at our add method, we're checking whether back equals queue.length, and it does, because it's 5 and the length of our queue is 5. We specified a length of 5 back here. The problem is there's all this space at the front of the array, and so our queue isn't really full. What we've done here is we've just hit the end of the array. And so even though 80% of our queue is empty, we're doubling the length of the array. And then if we keep doing this add remove thing, at some point we're going to double it again and double it again and double it again. Now our array was only started at length 5. What if you started an array at length 1000 and you kept doing this add remove stuff? By the time you get to the end of the array, you're going to have over 990 empty slots in the front of the array, and you're still going to go ahead and double the size of that array to 2000. So it would be nice if we could use the empty space at the front of the array, and we can if we wrap the back of the queue to the front of the array. And when we do this, this is called a circular queue, and we're going to update our implementation to do that. So rather than incrementing back to 5, we'll wrap it to the front. And so our queue will actually, the front part of the queue will be at the end of the array, and the back part will start filling up at the beginning of the array. And that way we can make use of all this empty space, and our queue won't have to be resized as often. So I'm going to close this off, but before I do, I'm just going to stop the debugger by hitting the stop button here. And now I'll close this off. And for now, I'll remove the breakpoint so it's not distracting. So let's go ahead and update this implementation so that it's a circular queue. We don't have to touch the constructor. Front and back are still going to start at 0. But we are going to have to do a different check here, because now, just because back equals queue.length, as we've seen, doesn't mean that the queue is going to be full. There may be empty space at the front of the array. And so we're going to use size here. And we're going to say if the size of the array is equal to queue.length minus 1. Okay, so that's resizing. Now, obviously, because we're wrapping the queue, we've got to change some code down here as well. We're still always going to assign the employee we're adding into the back of the queue. That doesn't change. But we don't necessarily want to just increment back, because we might want to wrap back to the front of the queue. So we're going to say if back is less than queue.length minus 1. In that case, we can just go ahead and increment back. I'll remove that increment from here. Otherwise, we're going to set back to 0, which means we're going to wrap it. All right, so let's take a look at what this code means for our case. So I'm going to add some comments in here to help. So if we add Jane to position 1, and then she's going to be the front, and then we come ahead and add John, and then we come in and we add Mary, and then we come in and we add Mike. Now at this point there's a position 4, and right now it's the back position. So I'll just put this out here. So after we've added Jane, John, Mary, and Mike, the front of the queue is still position 0. The back of the queue is currently pointing to 4. It's the next available position. Now we want a circular queue. So if we come in here and we add Bill, we can't wrap back to the front because that's not the next available position. When we add Bill in here, we want the next available position to be 5. And that means that we're going to have to resize the array. And so in this case, the size, which is 4, is equal to queue.length minus 1, right? Because queue.length, which is 5 minus 1, is 4. And that means that we've got our size is 4, they're equal. And so we need to resize the array because we want to be able to add Bill in here and increment back to 5. And so once we've done that, we'll assign Bill in here. So assign Bill. So we're going to put Bill in here, and because we've resized the array, we're now going to have 5, 6, 7, etc. up to 9. And so when we do this test here, we're going to say is back less than queue.length minus 1? Well, yes, it is, because the new length of the queue is 10, and back is less than 9. And so we can just safely go ahead and say we've added Bill, and now here's the new back position. And so this is why we have to resize the queue when we're one element short of the length of the array, and that's why this test down here is good, because once we've resized the queue, we know that back will be less than queue.length minus 1, and we can just go ahead and increment it. But now let's take these guys out. So we can look at the case where we're doing the alternating adds, so we can see what other situations we can get into. And so again, we're back to 0, 1, 2, 3. So in this case, we add Jane at the front, and then we're adding John. And after we've added John, we have this situation, right? And then we come in and we remove Jane. And so our front's going to come here. And I'll take this out, and then we add Mary because we're doing these alternating adds. So Mary comes in here, and our back position gets incremented by 1. And then we're removing John. So our front comes here. And then we come in and we add Mike, and our back gets incremented. And then we remove Mary. So our front is now here. And now we want to come in and we add Bill. That's all cool. And we're not going to resize because when we do the test here, we've only got one employee, Mike, when we came in. And so we don't need to do a resize. We're going to add Bill into back, which is currently 4. And then we do this check and we say if back is less than q.length minus 1, well, this check fails because back is 4 and q.length minus 1 is 4. So it's not less than q.length minus 1. And so because of that, we drop into this part and we wrap back to the front of the queue. And so this here will be the new back position, which is correct because then when we add Jane for the second time, we can come put Jane in here and increment back. All right, so let's keep going with this example because as you're going to see, we have one more change to make to our add method, and you might have caught that already. So let's say we go ahead and add back John, and then we increment back to here. Well, when we come in and add, let's say, I think it's Mary again, there's room for Mary here, but we can't increment back. So we are going to meet this condition because we have 4 items in the queue, and so this condition is going to be true, and we're going to go ahead and resize the array. But if we just copy in the elements exactly as they are, that obviously won't work because if we add Mary in here, it doesn't matter if we've added elements at the end. We can't increment back. So we have to change how we're resizing the array. When we resize the array, we're going to unwrap the queue. So basically, we'll copy the elements from the front of the queue to the back of the array into the front of the resized array, and then we'll add the remaining elements in the queue to the end. And so after we've resized, our front will be reset to 0 and the back will be the size, will be the number of elements because that will be the next available position. So in this case, after we've resized the array, we're going to end up with the following. So we'll have Mike at position 0 because he's at the front of the queue, and then at position 1, we'd have Bill. At position 2, we'd have Jane. At position 3, we'd have John. And then at position 4, that'll be pointing to back. And then we'll have, if we doubled the length of the array, we'd have, positions 5 up to position 9 because we would have doubled the array. So we're going to have to change the code in here so that if we're butting up against the front after we've wrapped, when we resize, we start the queue from the beginning again. And as you can see, we're in the same situation here as we were if we added 4 employees and then wanted to add a 5th. Here we've added 4 employees when we've wrapped the queue, and we still get into the situation where we can't increment back because if we do, it's going to be pointing to something that's already occupied. So when we have 1 fewer items in the array than the length of the array, it doesn't matter whether the remaining free spot is at the end of the array or somewhere in the middle of the array, we still have to go through the resizing because we have the same problem of not being able to increment back, or in the case of at the end of the array, we can't wrap back to the beginning of the array. So let's change our code in here to resize the array and copy the elements in such that we'll take the elements from the front of the queue and copy them to the front of the resized array, and we'll copy the elements in so that when we're finished, our front is reset to 0 and the elements are in the order they were added and the back will be at the end. So essentially in here, we're not just resizing the array, we're also moving the queue. We're unwrapping the queue potentially and moving it to the front of the array.